Your phone buzzes, you pick it up before you've even decided to. Your thumb moves on its own. You already know there's a good chance it's nothing important, and yet you check it anyway. That's strange, isn't it? You are a smart, capable person, you have things to do, but a small rectangle of glass in your pocket has more control over your attention than almost anything else in your life. Why? The easy answer is that phones are addictive by design. That's true, but it's not the real answer. The real answer is far stranger. Your brain isn't reacting to your phone. It's reacting to a system that existed long before phones, before screens, before electricity itself. A system built by evolution to keep your ancestors alive. To understand why you can't put your phone down, you have to go back about 2 million years to a hominin walking across the grasslands of East Africa, scanning the horizon for food, for danger, for anything unpredictably. Unpredictability was the whole game. A rustle in the grass might be wind, or it might be a leopard. A distant shape might be nothing, or it might be a herd of antelope, which meant meat, which meant survival for another week. The brain that paid close attention to uncertain signals, the brain that got a little jolt of motivation every time something new appeared, had an edge. It found more food, it avoided more predators, it passed on more genes. That jolt has a name, dopamine. People assumed dopamine was the brain's pleasure chemical. You do something nice. Dopamine rewards you. You feel good. Simple. Except that's not quite what's happening. In the 1990s, neuroscientist Kent Berridge ran a series of experiments on rats that changed how scientists understood this chemical entirely. Berridge found that dopamine isn't about pleasure at all. It's about wanting. It's the anticipation circuit, not the satisfaction circuit. Rats with dopamine blocked couldn't feel motivated to seek a reward, even though they still enjoyed it once they got it. The wanting and the liking turned out to be two separate systems, running on two separate chemical pathways. That distinction matters more than it sounds like it does, because it means your brain isn't built to reward you for having something. It's built to reward you for chasing something. The moment right before you know what's behind the rustle in the grass. The moment right before you turn over a rock. The moment right before you check the phone. Your ancestors lived inside a world made almost entirely of these moments. Every walk through unfamiliar territory was a slot machine of information. Will there be berries over that hill? Will there be a threat behind that tree? The brain that got a small dopamine hit just from the possibility of new information before it even knew what that information was kept exploring, kept scanning, kept surviving. Think about how demanding that kind of attention system actually was. Your ancestors couldn't afford to tune out. A predator only needed to be missed once. So the brain evolved a kind of low hum of vigilance, always running in the background, always ready to spike the moment something unexpected entered the field of view. That hum never fully switched off, even during rest. Even now, sitting still, your brain is quietly running the same background process, waiting for something worth noticing. Now here's where it gets stranger. In the 1950s, a psychologist named B.F. Skinner was running experiments on pigeons in what became known as the Skinner box. He wanted to understand how rewards shape behavior. He gave the pigeons a lever, press it, get food. Simple enough, but then he changed the rules. Instead of rewarding every press, he rewarded presses randomly. Sometimes the pigeon got food on the first try. Sometimes it took 20 tries. There was no pattern to predict. What happened next surprised even Skinner. The pigeons didn't lose interest when the rewards became unpredictable. They became obsessed. They pressed the lever more, not less. Skinner called this variable ratio reinforcement, and it turned out to be one of the most powerful behavioral patterns ever discovered. Predictable rewards create habits. Unpredictable rewards create compulsions. Sit with that for a second. Unpredictable rewards create compulsions. Skinner's pigeons weren't unusual. They weren't especially foolish or especially weak-willed. If you can even say that about a bird, they were simply running a very old, very common piece of animal software. The same software runs in rats, in monkeys, in humans. Big slot machines in Las Vegas are built almost identically to Skinner's box, and casino designers know it. The lever became a handle, then a button, then a touchscreen. But the mechanism underneath never changed. Uncertainty plus reward equals compulsion. That equation is older than psychology itself. Skinner just gave it a name and proved it in a lab. Now think about your phone. Every time you unlock it, you don't know what you're going to find. Maybe it's nothing. Maybe it's a message from someone you care about. Maybe it's a notification that makes your stomach drop or one that makes you smile. You genuinely cannot predict it. And that unpredictability is not a design flaw. It is the entire design. The engineers who built the apps on your phone did not invent this mechanism. They found it. It was sitting in a stack of behavioral psychology papers from the 1950s, waiting to be applied to something other than pigeons. Every pull to refresh gesture, every infinite scroll, every red notification bubble is a lever in a Skinner box. And you are the pigeon and the food pellet is information. Sometimes it's good information. Often it's nothing at all. Your brain doesn't care. It only cares that it might be something. This is where the ancient system and the modern trap intersect perfectly. Your ancestors' brains were built to scan for unpredictable, survival-relevant information in the environment around them. That system worked beautifully for 2 million years because the environment could only produce so much unpredictable information in a day. A rustle in the grass, a change in the weather, a stranger at the edge of camp. The system had natural limits built into the pace of the physical world. Your phone has no limits. It can generate an infinite stream of unpredictable, seemingly relevant signals every few seconds, all day, every day. The neuroscientist Robert Sapolsky, who has spent decades studying stress and reward systems, has pointed out that dopamine spikes are actually highest, not when you receive a reward, but when a reward is uncertain and about to arrive. That's the exact moment your thumb hovers over the screen, not when you read the message right before. Sapolsky's research goes further than that. He has studied how anticipation itself can become more powerful than the reward it precedes. In some of his work with primates, dopamine activity spiked hardest during the uncertain waiting period before a possible reward, higher than during the reward itself, and higher still when the odds of getting that reward sat right around 50%. Not guaranteed, not hopeless, right in the middle where uncertainty is at its peak. That is exactly the emotional territory your phone lives in. You never know for certain whether unlocking it will be worth it. That not knowing is the hook. Your brain, running software optimized for the savannah, has no idea it's being exploited. It thinks every notification might be food. It thinks every red bubble might be a predator worth investigating or a resource worth claiming. It cannot tell the difference between a genuine survival signal and a marketing team's carefully engineered engagement loop. Why would it? Nothing in 2 million years of evolution prepared it for infinite, algorithmically optimized unpredictability. There's something almost unsettling about this. You didn't choose to be vulnerable to this pattern. You were built this way by forces that had nothing to do with phones, screens, or apps. The same trait that let your ancestors find water in a drought, avoid ambush predators, and locate distant food sources is the trait being quietly rented out to hold your attention for a few more minutes a day. It helps to notice how deliberately this system gets reinforced. Big app designers talk openly in interviews and internal documents that have surfaced over the years about engagement metrics, time on app, session frequency. These aren't accidental side effects of good design. They are the design. Infinite scroll removes the natural stopping point your ancestors' environment always provided. A grassland eventually ends at a river or a cliff. A feed never does. Pull to refresh mimics the exact motion of a slot machine lever, a satisfying physical gesture that resolves into an unpredictable outcome every single time. None of this is subtle once you know what to look for. It is applied behavioral science running quietly in your pocket. But here's the part that changes how you might think about it. Once you know the mechanism, it starts to lose some of its grip. Not all of it. You are still a person with an ancient brain living in a world engineered to exploit it. But understanding why the pull happens gives you something your ancestors never had. Distance, insight, the ability to notice the hook instead of just feeling it. You can start to ask a different question when the phone buzzes. Not what is it, but why do I feel like I need to know right now? That question alone does something interesting. It moves the moment from instinct into awareness. And awareness is the one thing a Skinner box cannot account for, because pigeons never asked why they kept pressing the lever. Some researchers have started testing this directly. Big studies on notification design have found that simply removing the unpredictability, batching notifications into scheduled windows instead of letting them arrive randomly, reduces compulsive checking significantly. It's not that people stop caring about their messages, it's that the ancient reward circuit stops firing on every possible signal because the signal is no longer unpredictable. Turn a slot machine into a scheduled delivery and the same information stops being compulsive. Think about what that tells you. The problem was never the content of the notification. It was the uncertainty around when it might appear. Your brain isn't addicted to your friends' messages. It's addicted to not knowing when they'll arrive. This has a strange parallel in the animal world that makes it easier to picture. Field researchers studying primates in the wild have long noted that foraging animals spend a surprising amount of energy investigating things that turn out to be nothing: a shifting leaf, an unfamiliar smell. Most investigations lead nowhere, but the few that lead to food or warn of danger are valuable enough that evolution kept the whole system running, false alarms and all. Your phone checking behaves exactly like a foraging run that almost always comes back empty, except unlike a grassland. Your phone can offer you a new foraging run every few seconds, forever, without ever running out of leaves to shift. There's a kind of strange comfort in that. This isn't a personal failing. It isn't a lack of willpower or discipline. It's a 2 million-year-old survival mechanism, expertly reverse engineered by people who read the same research you just heard and pointed it at your pocket instead of a savanna. Your ancestors needed to notice everything uncertain around them, because uncertainty used to mean opportunity or danger. Today, it just means a red dot. It's worth asking what your ancestors would make of this if you could show them a device that never runs out of rustling grass. A world where every single moment of the day could deliver a tiny dopamine spike on demand, with no walking, no hunting, no risk, no reward beyond the spike itself. They spend their whole lives managing scarcity. You are the first humans in history who have to manage an artificial abundance of exactly the signal their brains were built to crave. So tonight, when your phone buzzes and your thumb starts moving before your mind has caught up, you might notice something. That reflex isn't weakness, it's inheritance. It's the same circuitry that once scanned grasslands for movement, now scanning a glass screen for movement of a different kind. The tool changed completely. The brain running underneath it never got the update. And maybe that's the real reason you can't stop checking your phone. It was never really about the phone at all.